This is my video for homework 3, question 1. Let p x equals k to be bk times p to the power of k minus 1. K is all positive integers and p is between 0 and 1. Problem A asks us to find b so that this probability represents a probability mass function. So we have to find b that all x for k's, all probabilities for x for all k's sum up to 1. We can start from considering this sum. We know that for p between 0 and 1, the sum of p to the power of k for all positive integer k's, it is 1 over 1 minus p. We can take differential on both sides of this formula with respect to p. We have that the sum of k times p to the power of k minus 1 is 1 over 1 minus p squared. And I call it equation number 1. In this way, we have constructed this sum. Note when k equals 0, this item is 0, so it doesn't affect the sum. We can write it like this. We can alter the lower limit here to 1, and the result remains the same. We have to find b so that this sum is 1. So we know that b is 1 minus p squared. Question B asks us to find expectation for x. Expectation for x is this sum. Then we can substitute it in and put the real value for b here. And then we have to find this sum. From a function, from formula number 1, we know that this sum is 1 over 1 minus p squared. So we can multiply p on both sides, and then we get this sum. Similar to A, we can take differential on both sides with respect to p, and then we get this sum. Sum of k squared times p to the power of k minus 1 is this expression. And then we can simplify it down to this. 1 plus p over 1 minus p cubic. And we can find the expectation for x to be 1 minus p squared times this sum, this very sum. And then simplify to be 1 plus p over 1 minus p. And then we have to find expectation for x squared. Similarly, the expectation is like this. And the sum we're looking for is k cubic times p to the power of k minus 1. So from this formula that I called number 2, we can find that the previous sum, the sum is this. And then we can multiply p again and take differential again, just like we did in A and B. We can find this expression, and we simplify it down to this. 1 plus 4p plus p squared over 1 minus p to the power of 4. So expectation for x squared is b, which is 1 minus p squared times this sum, So, and then if it is 1 plus 4p plus p squared over 1 minus p squared. Question D asks us to find the ex squared minus e squared x. That is expectation for x squared minus the expectation for x itself squared. That is easy to find. Simply do the calculations because we already know the expression for x and x squared. Simply put it inside and calculate. Problem E. Let p to be 1/3. Find the conditional probability mass function px equals k when x is between 2 and 5 included. So we can calculate b because we know the expression. We know p right now. It is 4/9. And x equals k is 4/9 times k times 1/3 to the power of, 1/3 to the power of k minus 1. We can transform this probability, and we know that it is like this. The sum of two events, that is over the probability of this event, that is to sum p x equals k for 2, 3, 4, and 5, and take the sum. That is this value. This is an exact value. So we can calculate, make the calculation. I'm sorry, make the calculation. Because this is a function for x equals k of k. This is a function of k, and this is a value, so we can calculate it to be this. All right.